All right, wow, welcome to geometry. We're going to continue on with geometry, unit 1, lesson 19. Now I run out of paper copies, so I'm going to try to have to do this the fancy technological way. All right, so we are on unit 1, lesson 19. We're going to start doing some circles and some arcs. We've done a little bit with circles, especially with construction so far, and we're going to continue on with our studies of circles. And the learning target today, you should be able to say, I can use the characteristics of circles and arcs to make mathematical inferences. We're going to use what we know about circles and arcs to make mathematical inferences today. So that's your learning target. That's what you're going to be responsible for learning today. All right. So, you've been seeing circles since you were a young kid, right? That's when we learned shapes before kindergarten even. So I'm sure you already have an intuitive sense for them. In geometry, we have a usable definition of a circle. It's a kind of a fancy thing. And so we're going to define circle as all the points that are equidistant from a particular center. So in this case, we might pick center A here. We might pick center A and say all the points that are equidistant from that center A comprise this circle. All right. So, exercise 1. Let's do this warm up while I take attendance. Exercise 1. A circle with an unknown radius is shown below. Circles are designated by their point at the center. So below, we would call this circle A, or we'd use this circle symbol A. So there is A, that's the center of the circle. We call this circle A because that's the center. Step 1 is for you to measure the distance between, I'm going to call for you to measure the distance between point A to points B, C, and D. Now, because I didn't print out a paper copy of this lesson and take it home with me today, I'm kind of doing this all electronically. I'll have to use an electronic ruler. Let's see how this works. Okay, I'm measuring the distance here, and I get 1.67. Let me change this now. Let me make sure I get the center right. It's centered really close. And now let me change where this goes. All right, let's try this. 1.68. 1.68. 1.68. Look at that. D is 1.68 away. Maybe 0.7, maybe 1.69, depending on how I measure. But I think a good measurement here is 1.65. That works. That's pretty close. And then what's the measurement of this one here? 1.68, 1.69. There we go, 1.68. So you can see here that all the points on this circle are exactly the same distance away. 1.67 if I measure it there. 1.66. I'm getting somewhere between 1.67 and 1.68. That's what I keep getting at when I keep measuring these over and over again. All right. So what's the measurement? AB here. Well, for AB, what do we measure? 1.68. Right? And AC, 1.68. And AD, 1.68. And I know we got some different measures. We got one, so every now and again we'd measure it and we get 1.67. That's because it's hard for me to get that with my little electronic ruler directly on the center dot. So things vary, and finding exactly where they vary here is also not easy. But we'll say approximately for our purposes here, 1.68. Now, maybe on the paper you have in front of you, it's not 1.68, and I'm guessing that's in. I'm guessing the measurement is in centimeters, but I could be wrong on that. I'm guessing this electronic ruler I have is not going to give you the same distance as what I have, so you might measure it with your own ruler and see how things are. B asks, what would be a big description of all the points on this circle? What would be a good description of all the points on this circle? What would be the description? Well, I'll need to delete all that. a good description of all the points on this circle. We might call this, they are all, again, I'm using an electronic tablet here to write these letters, equidistant. So I have to write slow. This is not as good as a pencil. And I can write nowhere near as neat as a pencil. Equidistant. That's the best I can do with the technology I have here. It's a little electronic writing pad, and as I write on the pad, it moves my mouse around. All right. They are all, actually, you know what? I need to say, I need a qualifier here. A qualifier. All. They're all the points are equidistant. All points. I'm sorry for how sloppy that is. I thought it better for me to make the video with the tools I had and then have it rather than not make the video and not have time during the week. It's break right now, so I'm doing these videos over break. So trying to get some of these done before too long. So all the points are equidistant, right? I wonder if it's easier to use other tools here. Maybe not. All right, I'm going to erase this then. Boop. All right, let's go to the next page. So a circle is just a collection or set of all the points that are a fixed distance, a radius away from a fixed point in the center's circle. We use this definition for all sorts of purposes. So let's, again, I'm going to use my electronic ruler here. Your ruler at home may vary. I'm going to use my electronic ruler to measure this. 3.34. Man, it looks to me like it's trying to measure in inches, because this is definitely measuring in inches. Let me see. All right, so my ruler is not to scale to the scale of this piece of paper here. I wonder if that has anything to do with the zoom I've got going on. No, I have 100% zoom in this document. So I don't know how to compare that. Sorry. So, sorry. Applause. All right, so locate and mark all the points that are both 2 inches from point A while also being 1.5 inches from point B. Well, so the best I have is this electronic ruler, so I'm just going to have to stick with it. All the points that are 2 inches, I'm going to get as close as I can get. There's one that's 2. Oh, nope. Let's see. I'm going to have to make this one expand out to 2 inches. All right. So I don't see I don't see any. Do I have a circle tool anywhere here? Ooh, I have a circle tool. That's kind of fancy. All right. I've got 2 points. I'm trying to line up my circle so that A's in the center. So the circle is going to be all. Whoop, I moved my circle. It's like a spotlight tool, more of a circle tool. So it's giving me a spotlight to kind of highlight something. So the circle of A, circle A, that is 2 inches from point A, is going to be all the points that are exactly the same distance away from A. All the points equidistant from A comprise circle A. And now I'll need to do the same thing for B. B, 1.5 inches. 1.5 inches, that's too much. Perfect. And then I'm going to try 1.5 inches this way. Ooh, I came pretty close on my first attempt. Oh, I didn't want to write that one. I'm going to undo it. Let me try again. 1.5. There we go. Now let me use that not so circle tool to make a highlight. B is the center. my circle has to touch both points, B being in the center. So I'm looking for, I need to make my circle a little smaller. Right there. Oh, right about there. Looks about good. So these are both 1.5 inches from point B. Each one of these is a radius. Oh, I moved my circle, sorry. If you have a compass with you, you do that right there. You measure 1.5 inches, all the points around B that are 1.5 inches. With a compass tool, that becomes a really easy job. If you don't have a compass tool, that gets a little bit harder. All right, I'm going to move on. So did we do everything here? Yes, we constructed all the things we needed to construct right there. Moving on. So moving into the exploration for today. So it's very important to be able to use a portion of a circle or a subset of points that lie on a circle. Circles are useful because all the points are equidistant. We can use circles to do all sorts of interesting things in geometry. And you've already seen how to do a perpendicular bisector with using circle arcs. You've learned how to bisect an angle already with a construction with circles. You've learned how to form hexagons with just circles. You've learned how to construct squares with just circles. So we've done a lot with circles so far. So this whole unit 1 is to introduce you to geometry. It's to get you used to the kind of things we're going to see in geometry. And now we're moving in and getting a little more specific, a little more technical. So a part of a circle, just a portion of a circle, we're going to call it an arc. So this here, arc GCF is an arc, and arc ECD is also an arc. These are parts of a circle, not the whole thing, but part. So exercise 3 is to construct arc BC with a center point A. Okay, so this is going to be really hard for me to do without a electronic device, without an actual compass here, but let me try this. I'm going to pick out a measure of 0.45. 0.45. There we go. I have a measure of 0.45. 0.45. Okay, so I have two measures of 0.45. Now I need to do an arc. Now without a circle tool, I'm going to be in trouble, but the arc's going to look like that's awful. But you get the idea. That's the arc. In blue, that's the arc. The portion of the circle centered on A that is a measure of, oh, I read this at 45, or 0.4, I read this as 0.45 inches, but now I see there's a little dot at the end here, which means it wants me to do an angle measure of 45 degrees. Oh my goodness. All right, well, to do that, we're going to need a protractor. I'm going to have to delete everything I did so far. All right, I need a protractor. Here's my protractor. I need 45 degrees. 45 degrees. Between 40 and 50, right there. All right, so I need to now mark this point in green. That's where my 45 degree measure is going to go. I'm going to actually make it that second dot there. And my other dot has to go here at 0 degrees. So from 0 to 45. All right, go away, protractor. Thank you very much for helping me out there. Oh, no, I didn't want another protractor. I wanted the protractor to go away. How do I make you go away, protractor? I guess I'm going to slide you out of here. I don't need you anymore. I have my green dot. So now I just need to connect my green dot from here to here. That's my 45 degree arc measure. And this one here, what did this one say it was? What length? 2.4. Okay, I'm going to try to reproduce that. Reproduce that to be 2.4. 2.4. I'm going to have to change this to when it gets 2.4. There we go. So I apologize. I don't have perfect tools here. It's a lot easier to do this on paper. Scooch. I don't think I need that kind of precision. I'm going to give up on that kind of precision. I'm going to say close enough. Close enough. The arc of that circle, and that's an awful arc, but that's the best I can do. I'm sorry. It should be a lot more round than that, shouldn't it? And I just can't manage. Let me try my fancy tool. trying to undo both of my green arc marks. Is my tool any better? Yeah, that's what I wanted. Thanks. Okay, so I can do better with my tablet, I suppose, than I can with the mouse, but I can only say marginally so. But you get the idea. There's my 45 degrees. There's my 45 degrees. 45 degrees. 2 points are equidistant from the center. Here's my arc. Arc B. B can be here, and C can be here. Arc BC, measurement of 45 degrees. Oh, it want. Look at this. Mr. Salt isn't paying attention to what he wrote. Radius of 4 centimeters. So, whew, I don't have that kind of tool with me. So I'm just going to keep it the way it is. 2.4. I'm happy the way it is. It's going to be 2.4 something. I don't even have a unit measure, so I don't know. Okay. Sorry for all that. We'll have to get rid of everything on our page. Go away. And there we go. All right. Exercise 4. Sorry, I should have paused before coughing in your ear. Creating an equilateral triangle. We've already done this, right? You've already done this. So this should be feel pretty good. Recall that an equilateral triangle is a three-sided figure with all three sides of the same length. All three sides of an equilateral triangle are all the same length. So what I kind of did here is I put a compass here, and I made an arc mark here on my page, and I took that same compass, keeping it the same distance, and made another arc mark. Well, where these two arc marks coincide, where they intersect, I'm going to get at least an isosceles triangle. However, it just so happens that this measure here between A and B was the distance between A and D. And then same distance as B and G, which means all these distances are the same between A. All the points between D and E are the same distance from A as are the points between B and GF, arc GF. So what I end up having here, I get an equilateral triangle because I kept all the same distances. An equilateral triangle has three sides of all the same distance. So now this side will be equal to this side, will be equal to that side. And I've done all that with arc marks and the help of some circles. The length of AB, shown below, is 2 inches and is used as the radius of these two arcs. All right. So they're going to intersect at C. So I drew in the segments AC and BC and explain why ABC must be equilateral. ABC must be equilateral. When someone says explain, you want to use the word because. Oh, I don't want that. I want to be able to write. Because I'm going to try typing this. That might be just that much easier for everyone involved. Boop, boop. Sorry, this does take a little bit more interesting. Oops, what have I done? What have I done? Oh, no, oh, sorry, apologize. I've told my computer to do things that I did not want it to actually do. It was kind of slow. This is what I wanted. I wanted a text box. I wanted to be able to move it around. No, don't go away. Okay, good. Okay, well, here we go. We're going to explain why this triangle ABC must be equilateral. Because all the distances between A and B, let's say A and B, B and arc GF, A and arc ED, are equidistant. Equidistant. All right, that means they're all the same length because all the distances between AB, so AB is, let's say, 2 centimeters. A to D is 2 centimeters. A to G is 2 centimeters. A to E is 2 centimeters. B to G is 2 centimeters. B to C is 2 centimeters. Well, if this is 2 centimeters, and this is 2 centimeters, and that is 2 centimeters, then what we have in front of us is an equilateral triangle. That's what we have in front of us. So if you need to write that down, you can pause the video here. I'm going to move on. Exercise 5. Using a compass and a straight edge only, construct an equilateral triangle using the segment MN as one side. Oh, I need to get some better tools. I'm going to pause this and see if I can find some better tools. All right, well, I looked for some other tools. I think that's what I'm going to have to stick with for the time being. I will investigate some other screen annotation tools. That's what happens when you're at the cutting edge of technology, right? You got to figure things out on your own. All right, so where was I? Use your compass and a straight edge. All right, so I have a straight edge here, but I don't have a compass. I'm going to measure this out to be 2.57. 2.57. This side needs to be 2.57. There we go. I'm just trying to get that close. Oh, well, I happen to have gotten really darn close just by guesstimating a 60-degree angle. 2.57 to get this precise. Okay, obviously, Mr. Solt is not completely on here. Obviously, this one. Uh-oh. No, that's not what I wanted. I wanted to select this guy here. But as you can see, real close, that I'm close but no cigar. My 2 points aren't quite where they need to be. I need to move the other one. I need to move them all a little bit differently to get that nice 60-degree angle. But you see the general idea. If I had a compass, I would take a measurement between M and N. I would draw an arc that would go from N all the way over to here. And then I would take that same compass measurement. I'd measure from N to M, and then another arc that would go through here. And where those two arcs met, that would be the point in which I would draw two equidistant legs from M and N, and I'd have an equilateral triangle. And then I could measure that with my ruler. But we're on the bleeding edge of technology of education here, right? So we're not going to be able to do that right here. I don't have a compass with the tools I have in front of me. All right. Oh, where'd my, Adobe Acrobat decided to do something. Okay. For each line segment shown below, use your compass and a straight edge to construct an equilateral triangle whose base is the line segment given, and B, measure each to the length aside of the nearest milliliter. I'm going to leave this to you. Use your compass, use your straight edge, use whatever tools you have to show me you know how to do this. If you freehand it, it's a 2. And if you're using your tools correctly, you get full credit. You go ahead and do this. Move on. Pause the video here if you need more time to do this. All right, here's our check for understanding. I'm going to cough. Hold on. All right. Number 4. Points C and D. Points C and D lie on circle O, as shown below. OC is 6x plus 2. OC is 6x plus 2. So I should, let's see, this is going to be, I wanted blue, thanks. 6, x, that's terrible, plus, this is awful. I cannot write small with this device. It's just not going to work. Let me try something else. Six. No, you're not going to let me type? I thought this would let me type. It made promises to me that it would let me type earlier. No, it just wants to select. Okay. I will try to use Adobe's tool then. If this is not going to give me what I want, I guess I'm going to be stuck with the Adobe's tool. All right. Adobe, don't fail me now. No, Adobe, don't do what you just did. I'm so sorry. Uh, so sorry. Again, bleeding edge of technology here. Uh, gotta get the technology to work with us here. Whew. All right. No, Adobe, I didn't want that. That's what I wanted. Thanks, Adobe. 6x plus 2. All right, thanks, Adobe. There, that was so much easier. I'm getting better at this. 10x minus 16. There, that's reasonable. That's reasonable. All right, then find the length of the radius of circle O. So if you know this is 10x minus 16 and this is 6x minus 2, you'll have to set up an equation. What equation do you know? Well, hopefully by now you know something about circles. You know that the radius of a circle, all the radii of a circle are always the same length by definition. It wouldn't be a circle if the radii had different lengths. So you could say, well, that means that 6x plus 2 will equal 10x minus 16. Your job is to find the length of the radius of circle O. Find out what x is, plug it into one of these equations, boom, you got it. All right, moving on. You might need to go back a second and then pause it and give yourself time to finish that. In diagram below, circles A, B, and C intersect each other only once at D, E, and F. So all these circles intersect themselves only once at D, E, and F. If the radius of circle A is 2 inches, 2 inches. Oop, nope, and then I go click off. That's 2 inch. And the radius of circle B is 3¼ Oh my goodness. 3 1/4 inch. Oh. And the radius of circle C is 1 inch. I guess that's not too bad. What is the perimeter of A, B, C? How would you solve this? Pause the video and think about this. This is very much a thinking question. You need to apply your mind. Don't give up. You have all the skills you need to solve this. You want to find the total perimeter of this triangle. How do you do it? Pause the video, give it a shot. Think about it. Well, hopefully now you're unpausing the video because you already have the answer. Well, I'm going to let you do the problem, but let me give you some more hints if you're struggling. If this radius is an inch, then this radius is an inch. If this radius is 2 inches, then this radius is 2 inches. If this radius here is 3¼ then this radius is 3¼ So my job would be to add 3¼ plus 3¼ plus 2 plus 2 plus 1 plus 1, and I'd have the perimeter of this triangle. That's set up just like a Regents question for geometry. After you get done with that, give me the reflection. Tell me what's working in the classroom, what's working in the videos, what needs to be improved in the videos. Mr. Solt, get your act together. Get a circle tool for crying out loud on these videos. Quit showing me all your mistakes, Mr. Solt. All right, okay, and the homework. Oh, don't forget our class credo, our 3 visions, and our vocabulary. Always there on the second to last page. Homework's always last page, so you can rip it off and take it with you if you don't want to do it in class. In diagram below, points A and B are 3 inches apart. Try to find 2 points that are 1 inch from point A and 1.5 from point B. Why do you think it's impossible to find such points? Let me think about this. The 2 points are 3 inches apart. Try to find 2 points that are 1 inch from point A and 1.5 inches from point B. Why can I never find such a point? Well, it's because the total distance between them is 3. And there's no way for me to get 1.5 to touch 1. They're always going to be at least a ½ inch short, right? I'm always going to be missing at least a ½ inch. So explain it why it's impossible. Use your compass, try to figure it out, try to see what you can do. But the reason why is because 1.5 plus 1 only equals 2.5, which will never close the gap of the 3-inch gap. 2.5 will not close a 3-inch gap. Number 2, using a compass and ruler below, locate 2 points that are 1¼ inches from point M and 2¼ inches from point N. Okay, I think you can handle that. Using a compass and ruler, you're going to locate points that are exactly those distance apart. So use your compass on M. You're going to use your compass and measure out 1¼ inch. Use your ruler to measure out 1¼ inch. Then take a compass measurement of that 1¼ inch. Do a circle or at least a half an arc mark between M and N. Go to N. Use your ruler to measure out a distance of 2¼ inches. And then make a little mark on that. Take your compass, take a measurement, copy that measurement of 2¼ inches, and then make a big arc mark around N at 2¼ inches, and find the 2 points where that will intersect. And then connect the 2 points you found in number 2 with a line segment, and then connect points M and N with a line segment. And what angle do you think these 2 line segments form? And use your protractor to verify. I'm going to let you do all that. I think that's good. We're at 32 minutes. Hopefully, you have hit your learning target. You can say, I can use the characteristics of circles and arcs to make mathematical inferences. You can use what you know about circles to solve geometry problems. That's all what we've done today. Congratulations. Have a great day.